In this Mathematica Sessions Q&A with Socheat, which is now episode 3, we're going to look at sketching functions, putting on the text as you see here in the picture. So how to do this, how to incorporate graphics in your images, and several other calculus principles that you might want to know about if you're studying microeconomics. So if you're interested in that, then keep watching. Thanks. So we just use the command sort, and we copy this, and we'll put a curly bracket around it.
Yeah.
So essentially, you're sorting the elements of an array, right?
Okay.
And so we'll press the button here, and you can see that they're in increasing order, so ascending order.
Okay.
Is that all right? Do you have any questions about that?
Yeah, and we'll just put a capital N in front of it to turn it into decimals? Get another view of it?
Yeah, well, you can. Yeah. So see what we have here, the recipe for those numbers, right? But in fact, I mean, if we even want to pull this out in front to make this simpler to look at, we'll just say S is equal to this, and then we'll say this is sort S. Okay, and then below, let's say T is equal to the numerical approximation of the of S. All right, so here you've got the numerical values underneath that. And then we can sort that too.
Yep, perfect.
Right. But we could do as you say. You could just say, you could just, do this. Put the N anywhere you like, either inside or outside, and you get the same result.
No, thanks.
All right. Does that make sense?
Yes, thank you.
All right. Now let's go for descending order. We've already got S in memory, right?
Yeah.
So what we do now, so if I call on S here, it'll display it, right? But what you want to do is take the sorted version of that, reverse that. Just by using the word reverse. And then you have it in descending order because you've taken the ascending order and turned it backwards.
Okay. Okay. Thank you.
All right. And if you want the numerical value of that, you can easily just do this. Put the N around it, and that takes the numerical approximation of it.
Thank you. Thank you.
Okay, now your next question seems to be about how you got those numbers, is it? Seems like you got them from a function. So
yeah.
let's pull that up.
Yeah, that's right. That's right.
Okay, so what would you tell me about this one?
So this is a function that we want to optimize. Sorry, not optimize. We want to find the max or the min over.
Yeah, okay, so I'll tell you a little story about that. Now, if you have a function, much like the one you're giving me now, and you want to find max and min, right? There are two possible definitions for max and min. Yeah. They're the local ones, meaning turning points locally, and probably in the context of economics, what you want to know are global maximum and minimum. And the global ones depend on the domain of definition, right? So you not only have to compare how high the local max and min are to each other to find the global max and min, but you also need to look at the endpoints of that domain, right? So for example, if you have the price of something depends on a quantity, for example, but you know that the company is not going to produce 100,000, then you've got to stop up at that point, right? And so if you were to look for max and min, you need to evaluate the endpoint as well on the domain. So there are a
Yes.
couple things to think about in that regard. But it looks like here what you're doing is you're basically subbing in some values and measuring how high these are, right?
Yes.
I mean, that's what it looks like to me. So I think this should probably go in one cell. So we'll put a semicolon after that one, and then we'll bring all of these under the same here, right? And so now it's kind of clear. Cut the rest of these if you don't mind. All right, so, and I guess maybe, are we missing some?
Yeah.
You something in the chat. Okay, I'll open it.
Yeah. This was the question.
Okay, right, gotcha. Okay, so what I'm doing is I'm turning this into an array. And then you've got f of 2 as well. Right, so I guess that's where you got those numbers from. And you know what, I'm going to show you an extra trick here, right? So let's include a little bit more information in this. So we'll go -1, 1, and turn all of these into points. So 0, f of 0, 1/2, f of 1/2, and then your last point is 2, comma, f of 2. Okay, let's give this a name. Let's call this W. Okay, so there's some points. And in fact, I mean, we can even take function and plot that together with these points. So I can say list plot W, and let's call this A, and then let's call B equal to the plot of this other one. We'll choose a suitable range. X goes from, say, 0 to 10. And then we'll say show the two of these together. All right, so I can see I didn't go far back enough. So let's go back to, say, -2. All right, so now you see those points. So that can kind of give you meaning to what you're doing, right? So it looks like you found some max and min points there.
Okay.
Do you follow that?
Yeah, thank you. Thank you.
All right, so now, I mean, what I can also do, having put W in memory as a collection of points, I can say let's take the jth element of W. Now this says, or let's call it the nth element, just so it sounds better. So this takes the nth element of W, we can reverse it. So that the height appears first in the list of pairs, and then we can tabulate this, all right? So as n goes from 1 to, now how many points do we have? 1, 2, 3, 4, 5. So 1 to 5. Let's have a look at this. Okay, so I put the y coordinate first in this, right?
Yeah.
And now what I want to do to that is sort that. Okay, so now we've got, now we were able to sort this. And so what you can do is associate each point with its order, right? Now you want to reverse each point again, but I'm just showing you some techniques for how to deal with lists.
Yeah.
So you can play around with that. Right now, if we call this something, like let's call this Q, I can do the same. Like I can say Q, let's pull out the n element again. And I want to reverse that because I've already sorted them. Now I want to put them in the correct order again. I can table that as n goes from 1 to 5. And let's see what we have. Okay, now we've got these points in which the y coordinates are in ascending order, right? So we've got the x coordinate as well. All right, just some extra things for you to play around with later.
Yeah, looks good.
I guess you don't need to know all of the full details just now, but yeah, you can fiddle around with those things. You get to know the functions, what you can do with them, and build on them.
Yeah, yeah.
Is that all right for that one?
Yeah, that looks pretty good.
All right, so your next question, number 3. For the below graph, can you show the value of the minimum point is with a dot? Okay, so first of all, do you know how to find that? I mean, do you know how to use calculus to find the dot at the bottom?
Yeah, so you just differentiate the function, and then you set it to 0 to get a gradient of 0. And then
Yep.
you can solve that derivative when you set it to 0. And then you'll get a value. And if you plug in the value into the original function, you'll get the point where it's either a max or a min. Or yeah.
Yeah, that's nicely said. Okay, so I've just put in some code here that gave the x value where that happens. So here, this says take the derivative with respect to x. And then this says solve for when that's equal to 0. But notice I've got 2 equal signs, right?
Yeah.
Okay, now let's call this something. I'll call this t, right? So t is that solution that says x goes to 1. But then let's pull something out of it. So we want to pull the inside out of it. Okay, so if I go t1, then I get this, and I do it again, as in put comma 1, I get what's inside that, and if I put comma 2, then I get the number 1 itself. All right, and so this is, well, this is the x coordinate of that point, okay? So next thing we want to do is, and I'll put above this, let's just go f equals that one. So everywhere there we can put f. Okay, and so I'll just call this one p. And down below we'll say replace all. Here I have a point. I'll go p, and then I'll take f. And I'll say x goes to p. All right, see what we get here. Okay, now we get your point 1, 2. So let's call that uppercase P. Okay, so we've got in memory as uppercase P is that point. Now you could have done all of that manually. I just want to give you some skills for how to use the computer to help you out with that, with finding that. So now we're going to call A your there. And then I'll call B list plot. And I'll put a bracket around this because you usually have multiple points. But now we put our uppercase P there. And then you probably want to include some options like plot style. And then we'll increase the point size. So the point size, and I usually pick 0.02 for this. Okay, so I'll run that and show you what we have. So here's your original plot, and then here's this point at 1, 2. Okay, so let's put semicolons on both of those to suppress the output, and then we'll say show the 2 of these together. All right, so now you've got your point here at the bottom. Is that all right?
Yeah, that looks good.
Okay. Do you have any questions about it? I mean, maybe I did a little bit too much code, so if there's anything about the stuff that you don't quite understand, just you can ask me anytime. Okay, so just pause and ask me anytime.
Yeah, there's got some more questions on it on the next one, on
Okay.
question 4.
Yep. All right. For the graph below, can you show the value of the redraw at the origin? Oh, I see. So what you mean here? So you're noticing that Mathematica has kind of chosen a dumb place to start the y-axis, right? Whereas you really want to show all of it. Now, I propose that what we do is we grab this code here and add on to this, okay?
Yep.
So, and I'll just put that underneath so you can see. All right, so we've included the point, but now you can go plot range. It's just another option on the plot function. All right, and now we want to choose a range. So let's say start from 0, and we'll go up to 15. And then, hang on, what's going on? Oh, there it is. Okay, sure. So I'll put a semicolon on this one here. All right, so how's that one?
That's exactly what I'd like.
That's what you wanted? Great.
Thank you.
Okay, good. Are you ready for the next question?
Sure.
Sure, okay. All right. For the graph below, can you show with a dot the stationary points? Okay, sure. So maybe we already did this, but let's just do this with calculus. So I'll show you that procedure again. So stationary points are these that you notice here, right? Turning points. We'll say f is equal to this function. And notice I'm not building a function here. I'm just saying f represents this symbolic expression. So this won't work as a function. It's just f is this symbolic expression. Okay, so given that, we'll take the first derivative of f with respect to x. So let's have a look at the output. All right, so we see this is it. It's a cubic. And next, what we want to do is, let's see if we can factorize that. Okay, so I'll say g is equal to this derivative. Let's have a look at whether we have any factorization of it. All right, so factor g. All right, so you see here, we've got a complete factorization. So that's handy because it suggests that you've actually got turning points that are rational numbers, right?
Yeah.
When you solve each of these equal to 0, you get rational numbers, but that may not always be the case, right? There may just be some nasty looking, well, real numbers, let's say.
Yeah.
As in not necessarily rational. So I'll show you another command here. So what we want to do here is solve, because you can find the roots of that derivative from looking at the factorization in that case, but not always. So what we want to do here is put solve e equals 0, because we're not setting that in memory as is equal to 0. We're just solving the equation.
Yep.
And you don't have to put comma x, but we'll just do it here. Okay. So let's have a look. So we see the 3 roots here: 0, 1/2, and 2. Okay. So now if you want to extract from that to get some points, we can do that, right? So we'll just give this a name. Let's call this W. Okay, and then we'll do indexing again. So say, for example, what is the first element of W? Okay, so you see it's this bracket, x goes to 0, but we actually want a number out of it. So we'll put comma 1. Okay, now we get x goes to 0, but now we want the number, so comma 2. Okay, now we have the number, but we got that by putting a 1 there. Now, if we put a 2, we'll get the number from the second one. And if we put a 3 there, we'll get the number from the third one.
Yep.
Okay. So now what I suggest do then, we'll put an n and we'll just say tabulate this. As n goes from 1 to 3. Okay, so now we've got a list of all the x coordinates of those turning points. But you also want the y coordinates.
Yeah.
All right, so let's give this a name. We'll call that t. Now, to get the y coordinates, we take the x coordinates and we sub those in to the value of f, right? So let's do indexing again. So say the jth one, okay, and then I want to basically say x goes to the jth one, and I want to replace all f as x goes to the jth one of that. But see, this is arbitrary. This doesn't talk about a specific element of this array t.
Yeah.
So now I need to tabulate that as j goes from 1 to 3. Okay, let's have a look. Okay, so now we get these points that look familiar.
Yeah.
But what we actually want are a pair, right? So we want to pair these with these so that we can display those on the graph. So let's fix this up a little bit, and simply by turning this part of it into a pair. So I'll put x comma f, and you're replacing x with those coordinates in here, right? So that's what we'll know. All right, and so here we have that. We've got these 3 points, and these are, what did you call them? Stationary points.
Yeah, that's right.
All right, great. So now that we've got that, we'll put semicolons on a few of these things. You can take those off later if you want to look at them. I'll give this another name. Let's call it A, and then we'll call this one B, and then we'll show the 2 of these. Oh, right, hang on. I want to call this lowercase a, semicolon, and then list plot that. We'll go plot style, point size, 0.02, and we'll call this one uppercase A. Suppress the output on both of these and show the 2 of those together. Let's see what we have. All right, so this is not quite what we wanted, right? And the problem here is that you want to see more of the picture.
Yeah.
So what we'll do is we'll say, because that goes to 3, right? So we'll say plot range all. Let's see if this does the job. Okay, but it's cut something off, hasn't it? So we'll go ahead and look at this. Or actually, have a look at this one. Yeah, so it's cut a lot of things off.
Yep.
So what we'll do is really specify. And I think I need to look this up now because it's not just, I don't want to just say go from -2 to 2, do I? Let's have a look. No, I mean, that doesn't do the job because much there is
what
missing,
I've noticed?
right? So let's have a, what's that?
Yeah.
Oh, right, okay. Yeah, that's, I guess, convenient.
Yeah. Maybe it's not so.
It does, yeah, but I mean, no, because see, we've also cut off the X and Y axis labels, right? So we really do need to fix this.
Okay.
Fix this by the code. So let's have a look at plot range, for example. So when you combine certain graphics, always get the range that you want, right? And so maybe, I think what I need to do here is specify the plot range in this one. So we'll just try this, and then if that doesn't work, we'll quickly just move on. So -1 to 3. Right, let's see. That doesn't look great. Okay. I guess we'll have to move on that because I don't immediately know the answer to that.
That's fine. Yep.
I've had a look at this already, and I already wrote up the code on it, but the challenge will be then to explain it to you in a way that doesn't basically overwhelm you. Okay. So this looks great. So that finds this intersection point. This is a function, so you're verifying that. That looks good too. Now, so you've got some things, characteristics of the photo. You want some black dots at these points. Okay, that's good. You want dashed vertical lines at q equals 10 up to the point E. Dashed horizontal lines at p equals 30 up to the point E. You want E itself labeled, and you want a black dot at E. Okay, and then this is a pretty nice image here. Let's resize it if we can, because it's taking up a fair bit of space. Did you draw this one by hand?
Yeah, I did. Yeah.
Okay, so here's where this starts. All right, so the first thing is this one. Having had a look at what you've got there. So this is the starting place for this. Basically, because in what you had, okay, so let's take this as well. Put it in the same expression. So what you had there, you had the orange one being, I guess, is that the supply curve or the demand curve? I don't know which.
Demand curve.
Okay, so the demand curve with a negative slope there. Yeah, so you've got that in orange pen, I guess, right? And so if you run this here, it's, your demand, that same curve is in blue, but you maybe wanted it orange, I don't know. So
Yeah.
a simple fix for that is to just reverse these, all right? Reverse the order of these two. Like that, and now the negative slope one is orange and the other one's blue. Okay?
Yes.
But another thing you might want to do is change the aspect ratio, right? Because you see from 0 to 25, it takes quite a bit of space relative to 0 to 50. So you can do that too, because in your diagram, it looks like, well, I don't know actually, because the 0 to the 25 looks about the same as 0 to 50.
Yeah,
Which
sorry
is
about that.
fine.
I was supposed to make it a bit bigger.
Oh, no, it's okay. I'm just saying you can specify your aspect ratio here as well. So in this one, I've done that, right? So I put aspect ratio 1. And well, it at least look more like what yours looks like. You see? So this is something I added to the code. Aspect ratio and then arrow to 1. And then I've done some other things. So axis style, and then we go directive. So I've made the axes red. I don't know if you want that, but yours in the picture look a little bit red.
Yeah, that looks good.
Yeah, okay. So, and bold as well. All right, so this is part of this, but of course you wanted a lot more. Okay, so the next thing is all of those points that you have in your picture there, you wanted those as black points. Okay, so basically all of those points I've got here in a list, and then I'm adding an option to that list plot. I'm saying let's choose 0.03 as the size, and let's make those black. Right, so I've got plot style. And then around that, because there are a couple different styles we're adding to the plotting of those points, we put those with a curly bracket. Okay, so I'll show that to you too. So you see they're nice and big, A with B. And now you can see here are your black points on top of that graphic. So you follow that okay?
Yeah, that looks good. Yeah.
All right, sure. Okay, so those are the points. Now, next, you wanted these green dotted lines, right? So for that, we can specify each of the lines here. So we've got a line from 0, 30, and 30, which is the intersection point. And then another line from 10, 0 to 10, 30, the intersection point. Okay, so I've called those L1 and L2, each of these. Right now, as is, I cannot add those to the graphic because I've got to say graphics. So for that, we need, yeah, did you have a question?
I'm listening. Thanks. Go ahead.
Sure. So right here, this is where I specify the two lines. And then here's, I say, to be graphics, right? And then I give the characteristics that we want for those. So you want it dashed and green. So you want those lines to be dashed and green. So we specify it like this, and we give it a name. And now we can combine this with the rest of the graphic. So we'll include it here. Okay, so now we've got green dashed lines. It might not be exactly the shade of green that you want, or the tone. I don't know which call. There's tone and there's shade, right? I forget which is which.
Yep.
But you can probably change that exact color by looking through the help file. Okay, so that's the dashed lines. Now the next thing you wanted is how do you add text onto this, all right?
Yeah.
So you want a specific text to add onto this, right? But first of all, you probably don't want the ticks on here if we're going to match your picture there. And you don't want the axis numbers there. You only want specific numbers on the axis. Okay, so we can do that. So let's go ahead and do that first, but we include that in the show part of it, or we can anyway. And so what we're saying here is plot all of it and don't show the ticks there. Okay, and then the last thing you want to do is show the labels on each of those points, right? So that's this piece. Now, again, we're using the graphics command, but we're going to specify text at each of the points. So I've got a bracket around all of it, and then I say text, and I put the quotations for exactly what the text is. All right, so here we want to put 0, 0 with round brackets. And then at this place here, we specify where to put that. Okay, so you notice the 0, 0 is the same as this 0, 0. But then I want to shift it left and down a little bit. So I subtract 1.75 from each of those coordinates as to where to place it. And likewise with the 25, I want it roughly at 0.25, right? But I need to shift it to the left by some amount. So let's say shift it 1.75 units to the left. And likewise with a lot of these, so we'll shift them. So this one here, the 10 will shift it down 3 units, and the 25 will shift down 3 units. And finally, the letter E, your intersection point, you want that at 1030, but just above that. So we'll add 3 units to shift a little bit. Okay, yeah. So that's the graphic, and now we want to include that graphic there, and let's run it. And so I guess this is approximately what you want, right? But you may want to play around with that and make it look better, for example. Yeah. Now here I can see that maybe that 0, 0 is right where you want it. And that's possibly because of the size, right? So you see if it's really small, it writes over it. So yeah, it could be the size, or you could just shift it over some more. Okay, now let's suppose you want to put this in a doc, okay? Say you're writing up a report on, the current state of the economy or something. Of course, this is microeconomics, so that's not the case. or how things are going in the business, for example, right?
Yes.
So at this point, you might want to call this something. So let's give this a name, this final graphic. I'll call it Y. All right, and then we can say export. And we'll just say supply demand, for example, dot JPG, if you want a JPEG file, and then I'll put a comma, and then I'll say we're exporting Y. Okay, and then we press the button. Now on my computer, this ends up in the documents folder. So it just displays that as the file name there.
Yeah.
But it's in the documents folder, so you can go and open your documents folder and find it, or wherever your computer has as the default folder for putting Mathematica files, right? And you can even say export that graphic as a PDF if you're using some software that requires PDF images, as some journals would require a PDF image rather than a JPEG if you're using that. And so just to show you that we can import them too, let's just say import supply demand .jpg. So we've got the quotations around it. And so there it is, but you can see it's kind of poor quality, right? Okay, so the PDF version looks fine. For some reason you got a bracket around it, but that's okay because the inside of the bracket is what you want.
Yeah.
Yeah. Okay, so I guess I go with PDF then.
Yeah,
For some
PDF
reason the
is good.
JPEG version doesn't look so great. Yeah. All right, so that seemed to be all the questions that you had there.
Yeah.
What else do you want to learn?
Yeah, I want to ask you some more things.
Yeah, go for it.
First of all, just a quick question. You know that goes to sign, that arrow sign, how did you type that in?
To write this. All right, now did you see what I did?
Yeah.
Let's say put this, which is minus sign, then put this, which is the greater than sign, then press spacebar.
Thank you.
Did you want to try that? All right, there are a couple other tricks that you might want to learn as well. Like, for example, just watch this. So hang on. So I need to clear all F. Okay, so F cleared. And now I'll say F1. Do you see how I did that?
No.
So I did that without the palette. All right. Control. Then, yeah, control and minus. Okay. There we go. Then minus. All right, so what would you like to know about this stuff?
Yeah, I just wanted to know the words in green at the bottom there, the numbered words.
Okay, so the numbers words. So some authors use different terminology. Right, so yeah, they have different terminology for maximum point. So this is basically saying so you have a maximum point of the function essentially if for all x belonging to your domain, now it could be a region with bounds, the domain D, or it could be infinite, right? So basically, if f of x is less than or equal to, that's right. So yeah, this describes a global maximum basically, because you have to check the whole region, right? And so this describes the global maximum, not just the local ones that you find with calculus. So this is saying that everywhere else is lower, essentially, or possibly equal to. So C gives an F value, it's the biggest. All right, so they say some authors use some different terminology. Yeah, that's right. I mean, you can write it in a different way, both in the order that you place the words and in the notation that you use. So I think it's fairly straightforward what it means, though. Okay, so find the maximizer of that. So another way to phrase this is to find the global max of this function where x is greater or equal to 0. Okay, so if you don't mind, I'll just rewrite this here. Okay, all right, so here's our function. So what you need to do here is find the local maximum first. Okay, so we'll do this with calculus. So we'll differentiate the function. First of all, let's call it f. F equals this. Differentiate f with respect to x. Okay, so there is our derivative. It's quadratic. Let's call it g. And then we want to solve g equals 0 for x. We've got -1 and -1/3. Okay, and let's call this s. All right, so we want s 1, 1, 2. That's the first one, which is -1. And we want the same for the second one. Okay, so these are, let's see, we want to point out of this, right? So let's just build this manually because that'll be a little bit quicker. Actually, I'll leave that there and then we'll go below and build each of the points manually. So we've got -1 and then we want to say replace all of the x's in f with this 1. That gives us the point -1,9.
Thanks.
All right, but we also have the point, let's -1/3. -1/3. Okay, that gives us this point. Now, so let's call this one P and the other one Q. Okay, and then, so what you really want to do is get a graphical image of this as well, right? And so you also have, you need to look at a third point because of the bound of the domain, right? So the third one is what happens when you sub in the boundary of the domain. Now in this case it's 0, right? Because that says x is greater or equal to 0. And so what we do here is we just replace x with 0 in f. Gonna get 9. Okay, so 0, 9. All right, so these are the 3 points we need to compare together with what happens to this as x goes to infinite.
Sure.
Right, so now for that, you either take a limit or you just plot the function. So let's look at the function. Plot f as x goes from 0. Let's just choose something like 25. Let's have a little look at it. Now the problem is when you compare that with the boundary of the domain, there is no maximum because that maximum is infinite. All right, do you see that? Because as x approaches infinite, the other end, this goes to infinite, right? Now let's have a look at this on a shorter frame, like where these points are. So as in, go up to 2 or 3, from -3 to 3, for example. Okay, so zoomed in, this is what you've got, right? So unless you have more information on this question, there is no maximum because the domain goes on and on after. Well,
Yeah, that sounds
the
good.
domain is all positive real numbers, right? Okay.
Yeah.
And include the points. So let's include B equals list plot. List plot. And so since we already have P, Q, and R, we'll go with that. Plot style, point size, 0.02, semicolon, show A and a B. Okay, so here are those stationary points. Now, you don't see a lot of turning there, do you? But if you restrict the domain a little bit, it's probably apparent. So let's go -2 to 1 instead on that. So -2 up to 1 for the x values. And so now it looks more like, oh, hang on. Right, so the x values there, they're below your domain, right? I see. Okay, so there's no maximum for this, but there is a minimum. There's a minimum, right? So I should just say that here for you, right? At the point, and it's the third one, which is R, 0, 9. I better write that in maths notation, so we represent as a pair. All right, anything else I can do for you, Frank?
I think that's all. Thank you very much.
All right. Sure thing.